Thank you. Hello and welcome to the February 28th Cluster API Working Group. I am your host, Chris Nova, and let's get started. So first on the agenda today, we have machine deployment, which we talked a little bit about last week. Does anybody want to jump in and give a little more color around that?
So for machine deployments, what we've been thinking about is mostly around how we would do upgrades of machines without actually having to write upgrade logic per provider. So you could, it's an analog of, so just like machine set is an analog of replica set to pods, machine deployment would be an analog of deployment to replica sets. And just like you can scale up and down replica sets or deployments, you'd be able to do that. And you can follow the same rolling update semantics for machine sets, where you would bring up a new machine set and slowly decrease the size of one and increase the size of the other. And it has a semantics of max unavailable, max surge, which we've thought about quite a lot, at least on GKE. So that's the primary thing. There are some open questions around how we want to do that for masters, because masters aren't really, they're more stateful sets rather than pods or replica sets. So we've been thinking around those. We're still thinking around that. So we just wanted to open that up to the community and get some feedback.
Is there a design doc or a CEP for this that exists anywhere?
It is. I can make it public.
Yeah, if we could share that and maybe PR it, that way folks have an opportunity to review it and give feedback.
Sure, I'll do that.
One thing we do in COPS, which may be helpful and has its own drawbacks as well, is that for the masters in a multi-master scenario, we run each in a separate, we call them an instance group, but in this case, there'd be a machine deployment. It's important that they run, for example, in specific zones in AWS. So that might, having the restriction that a master deployment might only have one member may make life easier.
What's the reason for only having one member per deployment with instance groups?
So specifically for masters on, the masters, at least on AWS and GCE, have etcd has a volume, and we want to be very sure that the instance is launched in the correct AZ. So we don't, although AWS has some best effort-ish guarantees that if you have, for example, a auto-scaling group with 3 AZs listed and 3 instances, that you will get one in each. It's not a hard and fast guarantee. And so we are very strict about creating, and we have the same problem with stateful sets, right? Where this is an ongoing discussion of how zones tie into stateful sets. So there is a, which has not really been resolved. There are some heuristics in Kubernetes, which are not very popular, but work. And I don't know what we want to do in terms of masters there.
Well, that brings up a really good point, which is what's the relationship between fault tolerance zones or availability zones, whatever you want to call them, and a machine deployment? Does the proposal touch on that at all?
No, so it's mostly around, it's targeted for nodes right now. It's not targeted for masters. So for nodes, it doesn't make a difference because you have machine deployments in each availability zone that you want anyways. So it's like, how would you go from one machine deployment in one availability zone to an upgraded version of that in the same availability zone, right? So we haven't touched on how that would relate to masters.
Also, to address failure domains in the Machines API would require a lot of thinking, because each deployment, each backend provider would have its own concept of failure domain. So you would need a generic way to express that in the API, because right now it's very provider specific.
Right. And I think that's really only relevant for masters in the case of running an HA deployment. If we're not running HA, then it's safe to say that everything could be running in the same availability zone, right?
Is that true? I mean, some applications, their HA depends on the fact that they're spread across zones.
No, I agree. I'm saying if we're not running HA.
Oh, okay.
Yeah, I think to get if you want to spread even if you just want to spread nodes across zones, you'd have to have one machine set, which means one deployment per zone, because zone is again a provider specific thing.
Okay.
So that actually goes back to the same question where maybe machine sets and machine deployments are not the way to think about masters.
And this was, when we originally started talking about the cluster API, we sort of envisioned the master definition to live outside of the concept of a group of machines. So I mean,
sorry, I didn't mean to interrupt. I just want to say, like, we do want to be, like, one of the trickiest things that I know COPS doesn't do absolutely correctly is sequencing the sequence of updates of the master components and the node components. So we definitely want it to be in scope of the API in terms of an upgrade of a cluster, even if, but we would then, if we didn't use machine deployment, we would need something else, I suggest, because I certainly would much rather that someone else wrote that logic for the cluster upgrade and that it applied across. I'm sure every like deployment tool would like to not have to figure that logic out each time. So, and it changes.
It should be a master deployment, right? Instead of a machine deployment, it would be specific to a master. Just like Stateful Sets has its own upgrade logic. And you would just write that once and have the machine controllers take care of everything else.
I think that's a good idea. I think if like then someone comes along and says they want etcd separately, and I guess then the question is, so like it becomes, do we have like an API type for each, or do we start doing roles or something like that in a machine deployment? That's a design question, I guess. So I will read the doc.
Yeah.
Okay, I'll start cleaning it up.
Okay, thank you.
One interesting and maybe semi-related question is if there are stateful sets running on top of Kube, and let's say there's three pods and they all have a persistent volume, let's say in each AZ, is there any kind of relationship between decision that there is really three AZs and that the underlying nodes, I guess, would be landed in three AZs such that you can actually bring back the pod with applicable disk in a particular AZ? Not sure if I described it well, but effectively, if the machine doesn't exist on AZ that you are expecting it to exist, then you won't be able to bring back a pod because you won't be able to attach the persistent disk.
You're absolutely right. We hit this in COPS a lot. So for the nodes, we do have a single auto scaling group that spans AZs, and we rely on the AWS sort of best effort guarantees. But some people want a stricter guarantee on their nodes as well, specifically because of this exact PV or EBS affinity. And so they will create separate instance groups or machine deployments, one for each AZ, so that they can really see, exactly the state of each and scale them independently.
Yeah, it almost sounds like we want a concept that's like a machine set in a way.
Is there I'm not too familiar with it. Is there a hard reason to attach a single machine set to a particular AZ versus have machine set actually span effectively and just decide what AZs need to be picked per node or per machine?
I think the reason is, how do you specify that outside of Amazon or AWS? AZ doesn't translate to every single provider, so there needs to be thought put into the API if you want to codify different availability zones or failure domains, whatever you call them, in the API. It can't be specific to a single provider.
So this is not to say that we wouldn't be able to eventually maybe spend that time, but for MVP, we're saying that it's potentially too much, or are we open to potential possibility here for even MVP?
Well, what I'm saying is I don't want a machine set controller or machine deployment controller that knows about specifics of a cloud provider. I think that's going in the wrong. I think that's the opposite of what we want to accomplish. We want these tools to be able to work across all providers. And
Yeah, I absolutely agree. I guess there's ways to pull out this AZ information to be more generic, right? Similar to how I believe there is a way to specify provider specific configuration for a machine, right? We could have a AZ object that has a provider specific configuration for a particular IaaS, right?
Why wouldn't that just
And then-
go in the provider config itself? Like, to me, that seems it's a part of that provider specific object we're already defining.
I think then you would at that point have to figure out how to, because the high level machine set wouldn't necessarily know that provider config is for a particular AZ, right? So maybe then we're saying that machine set really deals with multiple flavors of, I guess, the provider configs, and somehow correlates that to which AZ needs to be, or which kind of a equalizing number of actual instances made based on that provider config or something like that. But that seems to be very, very generic versus introducing something more first class like an AZ or maybe a different name that would have its own provider specific things, and then having the machine set know more explicitly about that this actually has, you know, relation to some notion of an AZ.
Can you elaborate on what would go into an AZ specific config?
Yeah, I'm actually one of the projects that I work on is Cloud Foundry Bosch, and we actually do quite a lot of it, right? From our own kind of experiences, for example, on AWS, the provider specific thing is just says availability zone, right? On Azure, for example, there is no notion of first class AZs today, so our AZ configuration is entirely empty. Now for GCP, it's I believe it's just zone and what else is there that's interesting? OpenStack, again, they also have just some availability zone first class configuration. vSphere, for example, we use clusters to represent AZs, so we ask to enter the cluster specific provider configuration. But itself, for example, the orchestrating component Bosch in this case actually doesn't know what it means. Like, what is an AZ? It just knows that here's the configuration that will pass down to a lower level component, like the what we call CPIs, but I guess there is a I don't know what the name is in this ecosystem, but the lower level component would know that this is specific to AZ and would somehow use those properties.
Yeah, I think that ties back to whether also we want to have a high level property on AZs, right? Like on fault domains. And of course, if you don't have fault domains, you have only a single domain there. But if you have multiple, then you could be able to specify. And I took an action item to file an issue on that. I think we should follow up with like maybe a more concrete proposal based on this discussion on what that would look like. So file an issue, and if anyone is interested, please feel free to pick that up and help with the issue as well.
Do you mind posting a URL in the chat for it?
Absolutely, I'll do that on Slack and also in the meeting notes. I have an item in the Google Docs, and I'll do that.
Thanks.
Just one comment. So this looks like a scheduler, but for availability zones. I mean, if you look at the pods, so in this use case, in my opinion, it might be worth to think about some logic about scheduling, but on the actual availability zone or something like this. So I don't know if it's worth mentioning.
Yeah, I'll add to the issue as well. Thank you.
Okay. Is there anything else on the machine deployment discussion?
No, I think that's about it for now.
Okay.
Thank you.
Yep. Moving on, we have cluster bootstrapping. Jessica Chen.
Yep. So I wanted to talk about how we could bootstrap a cluster with the cluster API and sort of open that up for feedback from the community and see whatnot. I have a link there that you can jump to the document, and I'll attempt to share it on the meeting. I can.
Which SIG you have authorized to use it, because I cannot access it?
I shared it with Kubernetes dev. If there's a better SIG to share that with, or a group, by all means, let me know in the chat and I will share appropriately.
Maybe also SIG cluster lifecycle.
Yes, that is probably a good idea. But I believe I'm sharing the doc, at least in the meeting right now.
Yeah.
Can you guys see it?
We can.
All right. The proposal, at least that I came up with, part of my goals for this is to have a bootstrap that is flexible to cover many types of setups, but it reduces code duplication, specifically in provisioning, and minimizes special case handling. So that were sort of my goals in designing this bootstrapping. So in terms of the world of possible setups, to have a cluster that is cluster API able, we need a couple components. We need to have an API server that actually has the machine objects and the cluster object, and we need to have controllers that can reconcile those objects with reality. And I'm going to call that the cluster API stack. So this stack can either live outside of the cluster or inside of the cluster. And there are advantages to both. The external one can recreate machines even if the cluster doesn't exist or the cluster is completely down, but then you need something to actually keep that stack healthy. That's external. Or if it's internal, then the cluster itself can keep that stack healthy, but if everything goes wrong or the cluster doesn't exist yet, you get into this weird chicken and egg problem. So my suggestion for bootstrapping is that what we should do is have our command line tool first spin up an external stack and then put those objects into the stack, and that stack will provision the cluster. And then optionally, we can actually move an external stack into an internal stack by pivoting, which is basically stop the external stack, copy over the etcd, and then start that stack back up. So that's sort of verbally what I think is a good way to do Bootstrap for clusters with the cluster API. Any thoughts on this, or?
I guess a couple questions.
Yeah.
You had mentioned a command line tool. Is this a command line tool that would be an artifact of the kube deploy repository?
Yes. Are you saying whether it lives in kube deploy or whether?
Right. Like,
sure, yeah.
Okay. So this is a proposal for a new command line tool?
Yes, or a change to the existing command line tool.
Okay.
The thing you run to provision your clusters.
Okay.
And I would say that we are open, to suggestions on what this command line tool should look like, or if it should be based on an existing tool. We know we have a lot of tools out there, and if it makes sense, if we envision functionality to be reusable, and that we should essentially based on some existing code base, we could also do that instead of just use this GCP command line tool that we had for the KubeCon demo.
Okay.
I mean, I struggle to see how, for example, cops would use a provided command line tool, but certainly the pattern and maybe some code absolutely sounds great. But I wouldn't worry. At least from my point of view, I wouldn't worry too much about creating a generic tool, because I expect most people will follow the pattern rather than trying to reuse the tool, I suspect.
And that's fair. That's fair. This is definitely, the way it's written, it is definitely more, an approach that minimizes duplication and whatnot.
But to clarify, in a GKE type environment for example, you might never do this pivot. You would always keep it as an external manager. Or that is an option.
Yes, yes.
That
Yeah.
seems really cool. I think there are a lot of people that want that scenario of like, you know, the GKE or on-prem GKE type scenario, which I think will make people happy.
Yeah, yeah.
Yeah, so one question about tooling. Do you guys think that this is something that like other tools that are out there, Kops, Kubernetes, would be interesting incorporating some of this functionality for bootstrapping, so they can enhance that instead of actually using this common tool? Because essentially, I think the challenge is find the right trade-off here, so we can have a common logic, so the bootstrapping and pivoting, etc., don't need to be replicated across all tooling that uses the cluster API, right? So trying to find the right trade-off. Any thoughts on that?
This is hard, and I would love to figure out the right way to do this that is a common pattern and do exactly the same thing in Kops. The thing which is really hard is where do you manage the objects after you've created them? Do you manage it in the command line tool, or do you manage it on the cluster? And then the complexity is what happens when the cluster blows up, for whatever reason. How do you then manage the recovery when you no longer have, presumably the answer is you manage it through Kubernetes afterwards. But then the problem being, how do you do recovery type scenarios? Or if you have to go back to the command line, what do you do? And that also happens in add-ons, right? So figuring out what we wanted the answer to be would be wonderful, and Kops would definitely leverage that pattern. Yeah.
This is something Wes Hutchins and I had talked about a few weeks ago, which was the importance of defining the sequence here. And then as far as actual implementation goes, if I could borrow code from Kube Deploy, that would be great. If not, having a step-by-step wiki scripts like we have here would be equally as valuable.
One question, I guess, regarding bootstrapping that I have is how would this integrate with some of the platform-provided Kubernetes experiences, like, for example, on GKE or on Azure or on IBM? They typically provide you some already, I guess, masters via their own tooling, right? Is cluster API too low level to create those masters, given that I guess customer doesn't have direct control over them and can't necessarily, they don't see the nodes for them, they don't see anything, right?
I think
go ahead.
I was going to say, if having the master, the control plane set up is already a solved problem, then in my eyes that kind of alleviates the value out of having a bootstrap process, because then at that point you can just deploy the CRDs and run your controller, and that should take care of scaling your cluster from then.
I see. Yeah, I'm just curious in terms of if there's some longer term plan to somehow convince some of the larger vendors to maybe to come up with some consolidated CLI experience of some kind that would work against their APIs. A lot of people potentially create the clusters in their CIs and whatnot. And if they want to kind of decouple themselves from a particular vendor, that a benefit to a generic CLI experience for getting a cluster up and running, I think is it's pretty big.
Well, I think that's a possibility here if we look at the importance of defining the sequence, and if that is an implementation, and to use Google, for example, GKE or GCE, those could be two independent implementations, and ultimately you still end up with a Kubernetes cluster, one of which is homegrown, the other one is a managed service.
I see.
But there is kind of an interesting point, which is the cluster adoption, maybe so to speak, if there's a cluster that is being managed, how do you get, the cluster API in it, maybe it's, running as a separate node or something that you can actually use in the same tooling against that cluster, right? That might be managed by a cloud provider.
Right. Yeah. To me, it's actually one kind of interesting idea is might be something to investigate is we just mentioned a few minutes ago about master deployment. Should there be some high level object that represents the the master that's provided by the IaaS, and then this tool just has a certain level of API, the generic API, to kind of interact with it, but doesn't see it as individual machines. And versus the rest of the machines are seen as you know, as the individual nodes, as a lower level components.
Yeah, that could be a case for a master deployment, and then abstracting that yeah, it expands, you know, the number of use cases we can support. Yeah, that's very interesting.
So next steps for the bootstrapping proposal.
That's a good question. Should I put this on the wiki, or because it doesn't seem like there's too much contention about this actual process here, or what would be the?
I would like to give at least give it a little bit of time for users in the broader community to provide feedback somehow. If that's in a Google Doc, that seems fine to me.
All right.
Yeah. So maybe we can pick it up next time and see if there's any concrete action items to come out of it.
Sounds good.
Cool. Moving on, if nobody has anything else. Cool. Next item, rename kubedeploy repo to cluster API or something more related to what we are going to help with discovery. Can we rename repos? Is that something that's in scope that we can do?
Yeah, I think that's kind of a part of the discussion here. You know, Sebastian suggested that a couple of days back, and it's like, yeah, kubedeploy doesn't really convey what we're doing, you know, and I don't know if that's a possibility. We talked about, you know, whether to move this code to a new repo or something, you know. So I don't know the history and like what we could do, you know. Go ahead.
To speak a little bit of the history and how we ended up here was when we started at this effort, we were in the locked repository phase of the Kubernetes project. So we ended up here because the repository already exists. There was originally talk of migrating this out to a different repository. If that comes in the form of a name change, then that seems fine to me. The one thing kind of related to this that I would want to call out is we've been talking a lot about implementing the cluster API for Kubicorn. And having the API separate than an implementation seems like something that would be really valuable. So maybe we actually end up needing 2 or more repositories here.
So that's an interesting point. Do you think like having the API separate, you know, like the way we have right now in different directories wouldn't be enough? Or do it like you're making a case for a separate repository, you know, to be really kind of have a better boundary?
The use case would be cyclical dependencies if we tried to vendor in the API and then put code back into the kubedeploy repo.
Yeah, I hit this using the API in COPS, which is using 1.9 API machinery because that's the released version. Yet I think kubedeploy is using 1.10 API machinery, which is incompatible. And I don't know how we solved that. I think that the way it's solved is it's split out into a separate repo, which I don't even know if we generate code in that repo or not.
And at that point, that just becomes the API definition and probably a Golang client as well.
I suspect this is going to be a long process if you don't want to be under a SIG. And so I suggest starting it now, but not bottlenecking anything on it.
I think that's a really good suggestion.
Because to clarify, it would be very easy. I think they were almost at the point where it's easy to get a Kubernetes GitHub/Kubernetes SIG cluster lifecycle cluster API. I think is it's not really clear yet, but we're like that seems easy-ish to do. I don't know whether stripping the SIG cluster lifecycle thing makes it harder. Cluster lifecycle prefix makes it harder.
Do you have any volunteers that can help with this process, or that might be more familiar than can help kick off this process?
I am working on an AWS one, trying to go through the process, and I will have more input on what that process looks like. I don't want to do 2 at once.
I'm happy to take this one and try to drive it.
We can work together.
Sure.
Yeah, yay.
Is there any particular reason why we wouldn't want it to live under the SIG for now?
I mean, no, this one's to you, Justin.
Well, I was just gonna say, like, I don't know whether we can have GitHub, just the name. I don't know whether we can get github.com/kubernetes-sigs/cluster API, or whether it has to be sig-cluster-lifecycle-cluster-API, which to me is a bit of a mouthful.
Yeah.
And may not help with our discovery goal.
If we had a cluster, if we tried to graduate our cluster API working group to the cluster API SIG, would that make things a little bit easier?
We could make the suggestion that working groups should also get their top names under Kubernetes SIGs, so that we don't have this problem. And maybe even that there's some sort of global allocation and we don't even need the WG SIG prefix, so that should, for example, someone decide that SIG AWS should be a working group of SIG Cloud, that we don't have to rename things. We can make the case. This is not going to be this is not going to happen it will be a miracle if this happened by next week, but Chris Nova achieves miracles.
Okay. I'll ping you offline, Justin, just to make sure I got my head wrapped around your two concerns there, and I'll see what miracles I can come up with.
Okay.
Thank you, Chris.
Sure. Anything else on repository structure? Is everybody kind of in agreement that the API and a potential implementation should live separately? Does anybody have any concerns there?
My only concern is that the type should be separate from the client, more or less, because in some cases you might not want to use the client that's provided, and you want to generate your own using type. So if you look at the Kubernetes, you have the API, and then you have the API machinery, and then you have the client Go. Yeah. So if you have the same thing, it will be perfect, especially for vendoring.
Okay.
Is tooling like node repair and whatnot, and maybe future additional kind of a new tooling, maybe in form of a CLI or whatnot, something that is considered part of the API, if you will, right? Because it would be nice if cluster operators don't necessarily have to worry too much about having different tooling where they go between, GKE, local one, some other one. Or is it more of a particular implementation? Or is there also maybe some blessed recommended implementation or something like that? Not sure if that really changes anything at this point, but just a question.
In my mind, the command line tool implementation of the cluster API would encompass things like the sequence of bootstrapping a cluster, and probably like mutating CRDs within a cluster after they've been, creating them, changing them, updating them. And then I think as far as implementations go, there's a lot of different ways we can look at having a plugin based model, or having just even like cloud provider based like style of working. That would be my thought, is as we start to venture down the implementation of the API, we can start to explore how we're going to start to track all of the different use cases for the thing.
I like the idea of having a cloud provider agnostic reference implementation for the cluster API.
Yeah, and that's where the sequence of things, it's a very linear process to bootstrap a cluster. So having an advertised well-known sequence would be convenient, and then allowing users to plug into that sequence.
Yeah, Jason, I think it was like that's the same thought that we had as well, that like some kind of a cloud agnostic way to do maybe some of the auto scaling, maybe the repair, and things that build on top of the API, maybe reference implementation, but that doesn't prevent others, from actually augmenting that or like replacing with a better implementation specific to the provider, right? And those might not be like that repository. I don't think we have a good story on how that's going to evolve into like more tooling around the API and where they should live. Yeah.
Anything else? Okay, next agenda item, proposal for deprecating the CID directory.
Hello. As most people know, in the past few weeks, I'm busy to migrating the old CRD based code to using the API application. So it's a slow process, but thanks to everyone for the patience. We are here already. So I'm making a proposal here. So from now on, please don't make a new PR attacking the old class API and the class API GCP directory. For all the in progress or under the PR under review, I don't hold on that. So please replace your code to the new API server directory. My plan is I like to give 1 week grace period. Let's check maybe next committee meeting. If 1 week not enough, maybe 2 weeks. So then we can just delete old directory. Everyone work on the new directory. I would like to hear the feedback. It's sounds like too crazy or doable.
So I think it seems like a reasonable ask of the community. What are the concerns of not doing this?
One of the concerns I can see people, for example, people still working on the machine set, initial machine set implementation. If delete old directory may cause some trouble for their experimental, their testing or so forth. So I think that's the only big PR going on right now. So I would like to hear their feedback.
Okay, and deprecating doesn't imply deleting the code, it just implies deprecating it.
Yeah, sure.
I think that seems sane. I have no issues there. Is the 1 week grace period, is that long enough for everyone? I'm gonna take that as a yes.
Yeah.
Okay. Anything else on deprecating the CID directory?
No.
Rad. Next up, forwarding requests to cluster APIs in scope for a cluster API implementation.
Yeah, so I'm just wondering if, for example, if I have a cluster API implementation running on running on some cluster that is reachable, let's say externally, but then it's managing one or more clusters that aren't reachable externally, and if users want to be able to reach those clusters APIs, they might want to use a proxy through this one sort of, I guess, management cluster or management API, sort of like we can do for individual services, let's say running on a cluster. Would it make sense to have something like a proxy sub-resource?
And that would solve the problem of having, we have one management cluster that is externally accessible, and then we have n number of internally accessible clusters, then we need to route through the external one to the internal ones. Your question is if the cluster API should support a proxy there.
Right.
I mean, I think it's a good idea. I think it's a sane idea. I don't know if a proxy is in scope for this working group, though.
I see. I mean, I guess I'm wondering how I would add a sub resource if it's not part of the API itself. So if the I'm not saying the implementation itself that can be left up to I guess whoever's implementing the particular cluster API, but just adding the sub resource to the API, would that be required, or is that just something that anyone?
I mean, I think that would probably be an exercise of how you're deploying your clusters, what your controller is doing, and how you want your proxy set up. If the proxy would live in the management cluster, then somehow you would have to ensure that either your cluster API controller is enforcing state there, or if it's just any old Kubernetes primitive, like maybe you had a deployment that would manage your proxies, Kubernetes could just manage it at that point.
Okay, I guess my question is just the sub resource doesn't that need to be added to the API definition?
If you wanted to implement it as a sub resource, that would be part of the extension API server. I kind of missed the first part of the description. Is this a proxy from the management cluster to actually control or to use the cluster that it's managing?
Yeah, to use the cluster that it's managing, right?
So this would be essentially like getting credentials to actually operate on that cluster, but just using a proxy instead. And
well, let's assume that you already have the credentials, but you just don't have to. You don't have a way to reach the API or the cluster that you're trying to use. But
I see.
You can do it through this.
Is this something that would fall under the purview of the cluster registry work?
That was one thing I was going to suggest. The cluster object has has status for API endpoints. Would it make sense to register a proxy endpoint there instead?
I see. Okay.
That may be something worth exploring. I'm not sure exactly how that would work, but.
Okay. Is that discussed in a different SIG or working group?
If we were going to represent it in the cluster status, like a proxy endpoint, that would be discussed here.
But in the meantime, Daniel said whatever the endpoint is not accessible, right? So I'm not sure how it's gonna be helpful. What he's asking right now is like a proxy from the class API server to the management cluster. Right?
Yeah, what I was saying is you set up a proxy separately, and you put the proxy's endpoint into the cluster status API endpoint, so that you're talking to a proxy that is specified in the cluster API endpoint, but it does proxy to the internal one that nothing else can reach. Instead of going through I'm just suggesting a way to get rid of the /proxy sub-resource and go about it a different way. The implementation of the proxy is still a detail that you have to solve.
Okay. Okay, thanks. That's a nice suggestion, actually.
Okay. Anything else on the proxy discussion? Anything else in general? Going once?
Who is going to KubeCon Copenhagen, actually? Okay.
I'll see you guys there.
Yeah.
Do we, wait, what?
I thought there was one more thing on the agenda. I'm sorry.
I thought.
Oh, no, it disappeared. I'm sorry. It's gone.
Okay.
It was about the cloud provider, but it's gone. It was your PR about the cloud provider. I don't know. Maybe I'm going crazy. Sorry. Ignore me.
Okay. Would it be useful for us to try to get some time as a working group in Copenhagen to do the in-person, face-to-face? We're not going to generate work, but we're going to talk about ideas stuff.
Yeah, exactly. So, like probably after a session meeting or something like this, in some bar or something. I don't know.
Okay, I can try to get us some time or something. I think it might be too late, but we'll see what we can do. Cool. All right, going once, going twice. Enjoy the last 10 minutes of the hour, everyone.